Hi guys, Mr. Lucchese here. I'm going to teach you a lesson about absolute value inequalities today. They're very similar to the equalities, the absolute value equalities that we've already seen, with a few small differences. Okay, so first, let's begin with a little bit of a review. So recall, absolute value is a question about distance. Absolute value is all about distance from zero. Okay, that's all it is. It's a distance question. Okay, so we said earlier when we were learning about it the first time was that distance is always positive, and that's something that we want to keep in mind this time, even though we're switching to inequalities. Okay, so let's just start again with a little bit more review. Let's say the absolute value of x equals 5. So in this problem, we are looking for a number x that has a distance of 5 units away from 0. Now remember, there are two different numbers that have a distance of 5 units from 0. One of them is the number 5, or positive 5. The other one would actually be negative 5. So there's two different numbers, 5 and negative 5, that have a distance of 5 units from 0. Now, let's look at an inequality. Okay, let's say that the absolute value of x is less than 5. Again, we're looking for distance, but this time we're looking for any number that has a distance of less than 5 units from 0. So we're looking at a range of numbers now. Okay, so it will not be 5 because 5, let me slide that up a little bit. 5 is exactly 5 units away from 0, and we want the distance to be less than 5 units away from 0. So it can't be 5, and it can't be negative 5, but it can be any number in between. So we're actually going to shade everything in between. Okay, so this is actually, it ends up being an and statement, which remember produces a sandwich. Okay, so we are looking at all numbers that are between negative 5 and 5. So we could also say that x is greater than negative 5 or x is less than 5. So this is an and sandwich. Okay, that's always going to happen when you're looking at an absolute value that is less than a number. It's going to be sandwiched around 0. Okay, let's look at the other situation. Let's say the distance is greater than 5. Okay, so again, we'll start with absolute value of x. The distance of x is greater than 5. Well, this is going to be the opposite situation. Okay, we're actually going to be looking at an or statement here. I'll graph it first. Okay, so we know that it won't be negative 5 and it won't be 5. Okay, because we're looking for greater than but not equal to 5. So if the distance is greater than 5, we're looking at the numbers out here. 5.5, 6, 7, 8, 100, anything that is bigger than 5. And the same thing will happen on the other side. Okay, we're going to look for stuff that is less than negative 5. It's got to be more than 5 units away from 0. Okay, so this is going to be an or statement. Remember, the graphs of these are extremes. Extremes. All right, so the arrows are going to be pointing in the opposite direction here. So if I wanted to rewrite this without the absolute value, I could say that x is either greater than 5, or we'd actually need to write the word or, x is less than negative 5. And so it's got to be an or statement. There is no one number that can be in both of those places at once. Okay. There are some special cases that come up that you should be aware of. Okay, and let's look at those. Let's say that the absolute value of x is greater than, let's make it negative 5 this time. Okay, so we're looking for a number whose distance from 0 is greater than negative 5. Well, recall, right, distance is always positive. So it doesn't matter what you pick here for x. It could be any number at all. The distance is always going to be positive, which is always going to be greater than any negative number. Okay, so this is going to be true for all numbers, for all x. It doesn't matter what it is. So if you have an absolute value greater than a negative, it's true for all numbers. Okay, so obviously, if there's a case that can be true for all numbers, there must be a case that is false for all numbers. And I can find that just by reversing the inequality to make this less than. Okay, as we said earlier, distance is always positive. So there's no way that the distance could possibly be less than -5 because it has to be positive. Okay, so that is going to be, you could say, false for all numbers. Or if you like, you can simply write no solution. There is no value of x that will make that statement true. All right. So other than that, and the little trick we learned earlier, when you multiply or divide by -1, this is pretty much business as usual with inequalities. Let's try a few practice problems so you can see how this might work. Okay, let's look at this one where we have 2 times the absolute value of x plus 3 is less than or equal to 8. Okay, now, one thing that I said earlier when we were dealing with absolute value, and this is my recommendation here, you do not want to distribute. Okay, you can get into trouble when you try to distribute using absolute value, so just avoid doing it. Okay, so I'll come back to the problem. 2 times the absolute value of 3, or x plus 3, is less than or equal to 8. So the first thing I want to do is isolate the absolute value. And I can do that by dividing both sides by 2. So we have a multiplier of 2 that's right outside the grouping symbols. So I'm going to divide by 2. That gives me the absolute value of x plus 3 is less than or equal to 4. Now, once you have the isolated absolute value, that's where you want to start thinking, is it going to be an and statement or an or statement? So here, I'm looking for where the absolute value is less than 4. Okay, so it's going to be grouped up around the 0. Okay, it's going to be a sandwich. We're looking for any numbers that are between 4 and -4. Okay, so x plus 3 is either going to be greater than -4 or less than 4. So it's going to be a sandwich. Okay, it's an and statement. And then I can solve this from here. I want to isolate the x, so I can subtract 3 from all 3 sides, if you will. So we're going to get x will be isolated, and -4 minus 3 is -7. 4 minus 3 is 1. So we are looking for numbers that are between -7 and 1. If we want to graph those, okay, so -7 and 1. It can be equal to -7. It says less than or equal to. It can be equal to 1. So the endpoints are going to be filled in, closed circles. And then we're looking for everything in between those. So this is a case where we were looking for an and statement, which creates a sandwich. Okay, let's look at an or statement where we're dealing with extremes. Okay, so another problem you might see, absolute value of x minus 2 plus 3 is greater than or equal to 8. All right, remember the first step is always to isolate the absolute value group. So I'm going to work outside of the group. I'm going to subtract 3 from both sides. That leaves me with the absolute value of x minus 2 is greater than or equal to 5. So I have my absolute value group isolated. Now I want to think, is it going to be an and statement or an or statement? So we're looking for where the distance is greater than 5, bigger than 5. So 6, 7, 8. Say this is going to be an or statement, which produces extremes. Okay, so x minus 2 might be greater than or equal to +5, or x minus 2 could be less than or equal to -5. So note, in addition to changing from 5 to -5, I also had to change from greater than to less than, or greater than or equal to less than or equal to. So remember, we're looking for things that are above 5 on the number line or below -5. We're looking at those extremes. So now we're going to solve these as though they are 2 separate problems. And we'll isolate x in both of them. So where we have x is greater than or equal to 7 on one side, or x is less than or equal to -3 on the other. And that whole thing is our answer there. It's an OR statement. If we want to graph it, we would graph it all on one number line. We've got -3 on the left and 7 on the right. Going to be closed circles on both because both of them can be equal to 7, equal to -3. And then x is greater than 7 has a shading to the right of 7. And x is less than -3 has a shading to the left of -3. So very similar to the compound inequalities that we did in the last lesson. It's just this time we're using absolute value to create those compound inequalities. All right, let's try one more. Call it a challenge problem before you move on to your exercises. Okay. This is going to be 3 minus the absolute value of x plus 2 is less than or equal to 2. Okay, again, we want to isolate the absolute value. So the first thing I'm going to do is subtract 3 from both sides to eliminate the 3 that's on the left side in that expression. Okay, so that leaves us with the negative, or the opposite of the absolute value of x plus 2 is less than or equal to -1. Okay, now note that we have not yet isolated the absolute value expression. We still have a negative here. Okay, so the way that we could get rid of that negative is think of it as if there's a -1 there. So I were to multiply that. If I were to multiply that entire expression by a -1, that would get rid of the negative. And I'm going to do the same thing on both sides. So I'll multiply the other side by -1. That leaves me with the absolute value of x plus 2 and +1. Now, recall the sneaky little trick that we discussed a few lessons ago. Whenever you multiply or divide by any negative number, that means you have to reverse the sign. So less than or equal to becomes greater than or equal to. And then we're going to proceed. So it took us a few steps to isolate the absolute value. And in the process, we also had to multiply by a negative, which meant flipping the sign. That's what made this a bit of a challenging problem. But from here on out, it's pretty straightforward. We're looking where the absolute value is greater than 1. So it's going to be an OR statement. It will be an extreme. So we're going to have to solve these as two separate problems. Either x plus 2 is greater than or equal to 1, or x plus 2 is less than or equal to -1. And then we're going to solve it. So we'll subtract 2 from both sides to get that x is greater than or equal to -1. Or when we subtract 2 from both sides over here, we get that x is less than or equal to -3. That's our full answer. Were we to graph it, we graph it all on one number line. We're looking at, -3 and -1. We have closed circles at both of those points because it can be equal to either of those endpoints. And then we're looking where x is greater than -1 and less than -3. All right, so I don't want you to stress out too much. Again, this is very similar to the last few lessons that we've done. We're just throwing in absolute value, which is just another way to create a compound inequality. I would like you guys, as your homework, to work the assignment that I posted on Google Classroom. And if you have any questions, please feel free to email me. All right, that's it for now. See you later.